Ladies and gentlemen, please take your seat for the most exciting show of the last 100 years. Einstein presents the Great Relativity Show!
Right. Now what's the first thing we have to know?
That light always travels at a constant speed.
Well, I have heard that before, but what does it mean?
Let's look at the motion of a speeding bullet.
Take that, you fiend!
The bullet travels at 500 miles per hour relative to the ground. But if the gun is shot by someone in a moving car, the bullet's speed relative to the ground will change. If the car travels at 50 miles per hour in the same direction as the bullet, then the bullet will now be going at 550 miles per hour. It's simple, yeah?
Only in the 1860s did James Maxwell, a scientist from Scotland, theorize that light might be different, that it would always travel at the same speed.
In other words, if someone shines a torch instead of a gun, the fact that they were driving in a car or standing still on the road makes no difference. Einstein was the first to take Maxwell's ideas seriously. He imagined what it was like to ride a beam of light.
Faster, damn it. Why does he not go faster?
Einstein knew that all of our experience of motion is relative. You cannot detect motion inside a space without reference to an outside point.
When the blind is down, they think they are stationary. Only when they look outside do they realize they are moving. I deduced that if the speed of light varied, then as your vehicle sped up, the light within it would change. You wouldn't have to look outside to see that you were moving. This was too ugly to imagine.
So now we know. Light will always travel at the same speed. So, the speed of light is measured in miles per second, in the same way that we measure the speed of a car in miles per hour.
Or speed equals distance divided by time. We know that in the case of light, speed cannot change, and therefore time or distance must.
But I hear you say, a second is a second is a second, measured by a great big clock in the sky.
What Einstein saw, and it nearly gave him a nervous breakdown to see it, was that our experience of time is variable.
No, there is no clock in the sky.
He claimed that moving clocks run slow.
In fact, this has since been proved. Have a look at this.
Two twin air hostesses. They have perfectly synchronized watches. One is on a plane, the other is in the terminal. The plane lifts off and circles the world. Arriving back, the clocks show a different time. One twin is a fraction younger than the other.
And when we talk about the distances involved in space travel, this makes a real difference.
But how do we explain this? It goes against all our everyday knowledge.
Oh, darling, that was wonderful.
Yes, the earth moved.
Yes, it did. Let me see your face.
The light traveled up from the torch, hit the ceiling mirror, and reflected onto her lover's face. The watch on her slender wrist measured a tiny but certain amount of time for that to happen.
But if I'm on the embankment, then I see something different. I see the light moving inside a moving carriage.
Thus, from the bank, the light beam appears to travel a further distance, and therefore from Mimi's perspective, it takes longer to complete its journey to the man's face.
And so time on the train is longer than time on the bank.
Thus proving that time is relative.
Now it's time for the most famous equation on Earth. E equals mc squared.
We've all heard of that, but what does it mean?
Well, I put forward the idea that light is the fastest thing in our universe. Nothing can go faster.
So what happens as you get near it?
What happens is that the force and work you put into going faster no longer turns into acceleration. Now it becomes mass. You get heavier and heavier, so you need more and more work to go faster. You will never reach the speed of light.
Energy is an amazing thing. It cannot be destroyed, but can only change its form. Take this car. When it comes to an abrupt halt, most of its moving energy will change into heat and sound energy.
But it will also retain a huge amount of energy as mass. That's its potential energy.
Einstein realized that there was a way to measure this potential energy.
To be precise, the energy of an object equals its mass multiplied by the speed of light squared.
So this equation shows energy, which you have when moving, and stationary mass, which you have when standing still, to be two sides of the same coin. So mass is energy waiting to be liberated, if you can find a way to liberate it.
Thank you and good night.